Hello children, in this video I am going to solve the mathematics CBSE mathematics board paper 2022. In the previous two videos I have solved section A and section B questions. Now let us move on to section C. This carries 4 marks each, 11 to 14. Question 11, 12, 13, 14 each carries 4 marks, and there is a case study type of question also. Now let us move on to the 11th question. Evaluate 0 to pi x by 1 plus sin x dx. We can solve this by using the properties where I is equal to integration of 0 to a f of x dx. I can use the property, this is also equal to 0 to a f of a minus x dx. I can use this property. So here we have integration of, let us take I to be equal to integration of 0 to pi x by 1 plus sin x dx. Now using the property, I will take this as I is equal to 0 to pi. In the place of f of x, I must take it as a minus x, right? So in the place of x, I should take a minus x, where a is nothing but pi. So it will now become pi minus x by 1 plus sine of pi minus x dx. But sine of pi minus x, you all know that sine in the second quadrant is positive. So this is now simply going to be equal to 0 to pi minus x divided by 1 plus sine x dx. Now let me have this as equation 1 and let me have this as equation 2. Now adding both, I will get 2I is equal to integration of 0 to pi. Now the LCM is going to be the same, the denominator is the same, so that is nothing but 1 plus sine x. So it is now going to be x plus pi minus x dx. Or x and x gets cancelled, so I can now take the pi outside, so it now becomes 0 to pi dx by 1 plus sine x. Now multiplying the numerator and denominator by 1 minus sine x, I will get it as integration of, so 2I is equal to pi integration of 0 to pi 1 minus sine x dx divided by, this is of the form a plus b into a minus b, that is 1 minus a plus b into a minus b is nothing but a squared minus b squared. So that is now going to give you 1 minus sine squared x, which is nothing but cos squared x. Now I can separate this as pi integration of 0 to pi 1 by cos squared x, 1 by cos squared x dx minus integration of 0 to pi. So I can put the brackets because pi is outside. So sin x by cos squared x dx, which is nothing but pi integration of 0 to pi 1 by cos squared we know is secant squared x dx minus integration of 0 to pi sine by cos. I can now split this as sin x by cos x into 1 by cos squared x, which is nothing but secant x tan x. So I can write this as secant x tan x dx. On integrating this, I will get it as, so this is equal to 2I. So 2I is equal to pi into integration of secant squared x is tan x. Tan x between the limits 0 to pi minus, and secant x tan x is nothing but secant x. Integration of secant x tan x is secant x between the limits 0 to pi. Now we know 2I is equal to pi into tan pi minus tan 0 is going to give you 0 only. So 0 minus secant pi is minus 1 and secant 0 is minus 1. So upper limit minus a lower limit. So minus 1 will give you minus 2. Also 2i is equal to 2 pi, or I is equal to pi. So the value is pi. Now moving on to the 12th question. A man is known to speak truth 7 out of 10 times. He threw a pair of dice and reports that doublet appeared. Find the probability that it was actually a doublet. This can be solved by Bayes' theorem. So now let me take the event PE1 to be telling the truth. So he says 7 out of 10 times he says the truth. That means it is now going to, so probability of the man telling truth is now going to be 7 out of 10. And let me take E2 to be the event he tells lies. So probability of the event he is telling lies is 3 by 10. So now getting a doublet is nothing but 2, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So you know the sample space when you throw a die, doublet. So a probability of throwing 2 dice is now going to be 36. So probability of getting a doublet is now going to be equal to, so we have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. That is 6 out of 36, which is nothing but 1 by 6. And probability of not getting a doublet is now going to be probability of not getting a doublet is 1 minus 1 by 6, which is nothing but 5 by 6. So the required probability can be solved by Bayes' theorem. So he is asking you what is the probability that it was actually a doublet. So it should be, so the required probability is 7 by 10. That is, the man speaks the truth, right? So 7 by 10 into getting a doublet is 1 by 6 divided by 7 by 10 into 1 by 6 plus 3 by 10 where he does not speak the truth, right? So 3 by 10 into not getting a doublet is 5 by 6. So on simplifying this, we get this to be 7 by 60 over, this is now going to be 7 plus 7 by 60 plus 5 3s are 15 by 60, which is nothing but 7 by 60 over 22 by 60. 60 and 60 gets cancelled, so the required probability is 7 over 22. Going to the 13th question, it's a choice question. Let me solve A first. Using integration, find the area of the region 4x squared plus 9y squared is lesser than equal to 36 and 2x plus 3y is greater than equal to 6. For these type of questions, especially for applications of derivatives, graphing is very, very important. So first let us graph the equations. So it is given as 4x squared plus 9y squared is lesser than equal to 36. First of all, let me make it as an equation. I'm dividing throughout by 36. I'll get it as x squared by 9 plus y squared by 4 is equal to 1. Or is lesser than equal to 1, or when I make it as an equation, I'll get it as an equation of an ellipse. And the other equation is, the equation of the line is 2x plus 3y is lesser than equal to, so 2x plus 3y is greater than equal to 6. Or I can write it as x by 3 plus y by 2 dividing throughout by 6, I'll get it as, I can make it as in the intercept form, is greater than equal to 1. Now we can see that a is 3 and b is 2 here. Similarly, a squared is, so basically it is now going to be the easy for you to graph it out now. You'll get the graph like this. So it's an ellipse. So this is now going to be the origin. This is going to be A, that is 3 minus 3. 4 is B. This is now going to be plus 2 and minus 2 here. And the equation of the line is now going to be when the A and B intercept, the X and the Y intercepts are 3 and 2 respectively. So it is now going to be 3, 2 here and 2, 0, 0, 2 here. So the equation of the line is now going to pass through this like this. Now when we graph it, when we graph the inequality, this will now become the required region where we need to find out the area. So the points of intersection are 3, 0. So this is 3, 0 and 0, 2 is the point of intersection. All right. Now the required area is now going to give you. Now the required area is now going to be integration of the area is now going to be the shaded region, which is now going to be under the curve. So it is now going to be the elliptical curve minus the straight line. So it is bounded between the elliptical curve and the straight line. That is the region we have to find out. So area is equal to integration of 0 to 3 y2 minus y1, where y2 is going to be the function of ellipse, and that is the elliptical curve, and y1 is now going to be that of the straight line. So I can now rewrite this as A is equal to integration of 0 to 3. Now the equation of the ellipse, I can rewrite it as, so it is nothing but x squared by 9 plus y squared by 4 is equal to 30, is equal to 1. So which is nothing but I making the inequality as an equation so that you can now substitute in the place of y2 and y1. So that would give you y squared by 4 is equal to 1 minus x squared by 9, or which is going to be equal to y squared is equal to, I can take the LCM out and write it as 4 by 9 into 9 minus x squared, or taking square root, I'll get y is equal to 2 by 3 square root of 9 minus x squared. Same way, equation of the straight line would be, this is going to be the equation of the ellipse. Now equation of the straight line, I can now rewrite it as, because we need to substitute in the place of y1. So that would give you 2x is equal to, so the equation of the line is now going to be 2x is equal to, you can rewrite it as 6 minus 3y, or y is equal to, sorry, the equation of the line actually is 2x plus 3y is lesser than equal to 6. 2x plus 3y is lesser than equal. So I can, now we need to take in the terms of y. So let me rub this up. So it is now going to be 2x plus 3y is equal to 6, or 3y is equal to 6 minus 2x, or y is equal to 6 minus 2x divided by 3. Or I can rewrite this as y is equal to, I can take 2 by 3 as a common factor, then I'll get it as 3 minus x. So already we saw it as nothing but y area, required area is equal to integration of 0 to 3 y2 minus y1 dx. So in the place of y1 we can now put it as 0 to 3. In the place of y2 it is now going to be 2 by 3 root over 9 minus x squared dx minus integration of 0 to 3, same way 2 by 3 into 3 minus x dx. Now we can take 2 by 3 as a common factor. 2 by 3 as a common factor out, and it is now going to be 0 to 3 root over 9 minus x squared dx minus integration of 0 to 3 minus x dx. Now this is of the form root of a squared minus x squared. The formula is x squared by 2 root of a squared minus x squared plus a squared by 2 sine inverse of x by 2. So this is now going to give you 2 by 3 into x squared by 2 root of 9 minus x squared. A squared is 9, so plus 9 by 2 sine inverse of x by 2 between the limits 0 to 3. Now integration of this y1 would give you 3x minus x squared by 2 between the limits 0 to 3. Now applying the limits, that would give you, so 2 by 3 is a common factor for both. So don't forget that. Put it within the brackets like this. So 2 by 3 into, on applying the limits, first when I apply the limit, upper limit 3, so 9 squared minus 9 minus 9 will give you 0. So obviously the first term is now going to become 0. Plus 9 by 2 into sine inverse of 3 by 3. And for the second one, it is now going to be minus 3 into 3 is 9. 9 minus 3 squared again, 9 by 2. Of course, the lower limit is 0, so we can ignore it. Now apply, simplifying this. Now you know sine inverse of 3 by 3 is sine inverse of 1, which is nothing but pi by 2. So 2 by 3 into 9 by 2, 9 pi by 2. I can write it as 9 pi by 2. So 9 pi by 4, because 9 by 2 into pi by 2, which is now going to give you 9 pi by 4. Minus 9 by 2 minus 9 by 2 is, now this is going to give you 18 minus 9 is again 9 by 2. So on simplifying this, we will get it as 2 by 3 into 9 pi by 4 minus 2 by 3 into 9 by 2. So this 2 and 2 will get cancelled. This 3 and 9 can get cancelled. Again, here also 2 and 4 you can cancel. 3 and 9 can get cancelled. So the final answer is 3 pi by 2 minus 3 square units. This is the required area bounded by the curves.